All right, everybody, welcome back to the Discovery Museum's DIY Science Lab, and welcome to our first ever DIY Science Lab Live. I'm Sarah.
I'm Michelle. Today, you guys are acting the part of our live studio audience.
Let's give you guys a big round of applause. All right, so while we film today's DIY Science Lab live in front of our live studio audience, you guys are going to get to see our next great trick.
All right, so why don't we just dive right in?
Now, as terrible as the joke may be, she is right. Today, we are going to be making something called a Cartesian diver. Now, this is going to work sort of like a submarine. Does anybody know how a submarine works?
No. That's all right. We can tell you.
We will help you guys figure it out. Does anybody know maybe what it does? Yeah. Excellent. A submarine is something that can go under the water and move around. But once it's down there, does it stay down there? No. What else does a submarine need to be able to do? It will also be able to move around, and then eventually it has to be able to do one last step.
It has a little thing on top of it that spins like a little helicopter.
You might be able to look around and use it to move, but eventually you need to come back up, right? If you want to go in a submarine, you want to be able to come back up to the surface. So it's not just being able to sink down, but also come back up. We're going to show you how to do that today with our very own Cartesian diver bottle.
So first you need an empty bottle. It really doesn't matter what size bottle you use. I wouldn't recommend the smaller water bottles, but anything normal size or bigger works fine. The important thing is that it is clear, so you can actually see your diver inside the bottle. You'll also need a bendy straw.
And some scissors for your bendy straw.
You'll also need some sort of modeling clay. We recommend ones that will dry and harden because you want it to be able to dry airtight. If it's still wet, it kind of falls off in the bottle and it doesn't really work that well.
So, in order to build your Cartesian diver bottle, the very first thing you're going to need is your bendy straw. And you want to actually bend it over all the way. Do you see how we have it bent and you can sort of see where it lines back up with the whole long piece of the straw? You actually want to cut your bendy straw right at that end, so that we end up with about even lengths on both sides. From there, you're going to cover it with your modeling clay.
Okay. When you're covering with the modeling clay, what you're actually doing is you are trapping the air inside the straw. The air is going to want to pull it up out of the water. The clay is actually going to weigh it down. That's important because you want this to be what we call neutrally buoyant. When something is positively buoyant, it floats right up at the surface like a piece of wood. If it is negatively buoyant, it'll sink down like a rock. Neutrally buoyant means when you put it in water, it kind of should stay exactly where you placed it. Not sinking, not rising.
And you can see that it's not quite down at the very bottom there, that it is floating about partway through the water.
Yep.
That's what you're looking for to check your diver to see if it's ready.
Now, once your diver is ready, what you need to do is you need to fill up your empty bottle all the way to the top. And I do mean all the way. When you put your diver in, water should spill over the edge.
So we have one here that we've already pre-filled. And you can see we have the water all the way up to the tippy top of the bottle. Now inside we also have a diver that we've already prepared. This one's made out of materials that are a little bit different. This one is actually a pipette with a little ballast nut on it.
There you go. Nope, it wants to do the ceiling.
Now as you can see right now, it is floating all the way up at the top there. But we can actually change that. Does anybody have a guess how we might be able to change what it's doing?
Tip it over the other way, then it's going to go to the other side of it.
We might be able to tip it over and then it would move, but certainly, don't you think if it's still floating, it might just float on the other side then? We want to see if we can make it actually sink. What do you think we need to do to make it sink?
The water pokes away.
Well, the water is definitely going to help us do it. In fact, what's going on here is all about density and pressure. You can see here that we have a little bit of air that we trapped in our straw, like we said before, and the same thing goes for this pipette. There's a bubble of air up at the top. What happens is when we squeeze the bottle, water tries to push its way into the diver and makes that air compress and become more dense, so it sinks to the bottom. As soon as you release the pressure, the water is able to leave again, and the air can expand and take up its space. The diver goes back up to the top. And you can see we have it so that it stays pretty well in the middle there. Pretty cool, right?
Now you can add on to this if you want. You can dress up your diver, make it look like a sea creature, maybe draw a shark face on it, maybe some extra legs for it to be an octopus, or you can add maybe a paper clip and some loops down at the bottom or rubber bands to try to pick up the rubber bands using your diver. That's always very fun. But this isn't the only DIY we're going to do for you guys today.
The other DIY we want to show you is another one that definitely is going to show you things moving up in the world. And this time it's going to be in the form of a rocket. Now this rocket may be small, but it is still pretty powerful. Here's how it works. We have a canister here, a film canister, that we're going to use as the body of our rocket. When the lid is on the canister, it's going to be as close to airtight as we can make it. Anything that we have going on inside this canister is going to stay in there until we make a change. We are going to take advantage of Sir Isaac Newton's third law of motion, which tells us that for every action there is an equal and opposite reaction. We are going to create a chemical reaction where we have water in our canister and some Alka-Seltzer tablets that are going to dissolve in that water and create a buildup of carbon dioxide gas. Eventually, the buildup of the gas will be so great that lid is actually going to be forced off of the canister, and we will see our rocket go
All right.
up.
Now, in this particular rocket, it's not very easy to time. What's happening is we have to wait for all the carbon dioxide bubbles to fill up that empty space and continue to build and build until there's no other place for the carbon dioxide to go but out through where the lid is, forcing the rocket up into the air. I am magic.
Miss Michelle has managed to say exactly the right cue every time we've done this all day. It's very impressive. So as you can see, the lid launched off and left behind a puddle of water from our experiment, and the rocket launched in the air. Now, you may have noticed that there's a specific ratio we wanted to use for this. We actually only filled it up with water about halfway, and that's because you want to leave room for that gas to build up. If you fill it up with too much water, then you won't have enough space for the gas to build up to create enough pressure to actually make the cap pop off. If you have too little water, you still won't be able to have enough gas made in your chemical reaction to really make it happen. So we're going to try this again. This time you won't be able to see the exact ratios we're using because we're going to use the one that looks like a rocket. Do you guys want to see it again?
Yeah.
Are you ready?
All right.
They do not sound ready. Are you ready?
Now they're ready.
They're ready.
So this particular rocket we made out of foam, but you can make one out of paper, any supplies you have laying around. I did the same thing. I filled it up halfway with water. I popped in half a tablet of Alka-Seltzer, the same as the original one. This one just looks more like an actual rocket. Okay? And like with the other one, what we're waiting is for all the pressure to build up until it's too much inside the rocket, causing it to actually launch up into the air. I am really good.
So as you can see, there are a variety of cool tricks that you can do with very simple rockets, even as a DIY project. Does anybody know of any other cool rocket tricks that they would like to share with us today? I think we might have a couple of people who are looking to share some rocket tricks with us today. Would you guys like to come on over and show off with your rocket skills?
I think we know a few.
All right, everybody, this is Dave and Elliot. We have them here to show us some tricks that we should not try at home. So we have shown you some of our DIY projects. We're going to call these our DDIY, our Don't Do It Yourself science lab. Okay, is that far enough?
That should be far enough back. Yeah.
Don't
The
do
key here is whatever they do, don't do it
do
home.
it yourself.
All right.
All right, super.
All right. We'll turn it over to you.
Thank you.
So Dave, what did you think of that rocket? You thought that was impressive?
Not really.
Think we could go a bit bigger?
Yes. Yeah.
What do real rockets run on, guys? Do real rockets run on water and Alka-Seltzer? How about real rockets that go into space? What do they use?
Fire.
Yeah.
Fire. They use fire. We need some fire.
Yeah, we could do that. Yeah.
What makes the fire in a rocket? Does anyone know? Fuel. So in order to fire, you need fuel and you need something else.
Yeah, we need something else. Some gas, but one of those.
Special kind of gas.
Special kind of gas.
Oxygen.
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 Need the right mixture of fuel and oxygen.
Rocket needs hydrogen.
Hydrogen would be considered one of the fuels, correct? That's right.
One of the most powerful fuels.
Yeah, more powerful fuel. you could probably-
More powerful than what we're using
I
today.
see a rocket scientist among us. Excellent. All right. So we're going to need a rocket engine. No, just happen to have one right here. That's right. So inside we happen to have our fuel, and we happen to have that oxygen. We're just about ready. Now, this is a carboy. You probably don't know what that means, but if you're making beer, you make it in here. That's where we get this from. So what we have here is this is a combustion chamber. It's going to basically contain the energy of that combustion between the fuel and the oxygen when we ignite it. When we ignite that fuel-oxygen mixture, hot gases will escape this way. And which way will our rocket go? Excellent job. Yeah, that's right. You guys are rocket scientists. Well, that way. Excellent job. If we had taken the rocket engine and flipped it upside down, and the hot gases go down, which way will the rocket go? You guys are rocket scientists. Excellent job. All right. I think we're ready to fire this engine.
So what could make this more dramatic if we're going to have fire? Could turn off the lights. Now, Dave, is this going to be loud?
Oh, it's going to be terribly loud. Yes.
So you might want to cover your ears. Is this going to be dangerous?
Oh, totally dangerous. Yeah.
So I should probably step a bit further away than this.
That is correct. Yeah.
All right, you guys are okay. Are you ready to see a little explosion in here? Yes. All right. I'm going to step back.
I'm just going to roll up my sleeves and expose all my arm hair to the engine. You guys ready?
It's pretty loud.
Oh, it's awfully loud. You guys ready? And we're going to have a countdown. Okay, are you guys ready for the countdown? Starting from 10, 9,
8, 7, 6, 5, 4, 3, 2, 1.
Was that cool?
That's right.
Was that loud enough for you guys?
No.
Who says that was loud enough for you? Raise your hand. Who says that wasn't loud enough? You want something louder? I think we can make it loud.
All right, I think we can help you. We do have something that is actually quite loud. Shockingly loud.
You guys want to hear some thunder? What makes thunder?
Close.
I heard someone say, what makes thunder? Lightning. We're going to make some indoor lightning today. So, to make lightning, we're going to use this Tesla coil. Has anyone heard of a Tesla coil before? So what a Tesla coil does is it amplifies electricity. It makes a lot of electricity. The electricity coming out of the wall is about 110 volts. What happens now? You never do this. What happens if you put a fork into an electrical outlet? What happens to you? You get electrocuted. So 110 volts is pretty dangerous, right? This does something very special. So the 110 volts goes into a converter, goes into this coil, which is an electromagnet. This creates a magnetic field which runs through this coil here, which is wound over 10,000 times. The magnetic field running through this coil creates electricity through the process of induction. This turns that 110 volts into 750,000 volts. That's 750,000 volts. So when you unleash that much electricity into the air, what do you think happens? Makes a big spark, and it makes a lot of heat. This heats up the air so much, it creates plasma, which is what glows. That's what you see in lightning, and it's the hottest state of matter. It also produces a lot of sound. If you're really afraid of loud sounds, I'll give you a little chance to leave. Also, does anyone in here have a pacemaker? Anyone in the audience have a pacemaker? This would mess with that. Okay, nobody has a base station. Excellent. All right.
Hang on.
Yep.
Nope.
That is metal. That will get struck by lightning. Okay. Is everyone ready to see some indoor lightning? Yes. Is everyone ready to hear some thunder? Good.
As long as you're on this side of the fence.
Is everybody ready? Yes. All right. I'm going to start it low, and I'm gradually going to crank it up. Ready? Here we go. I hope you all enjoyed the show. Of course, do not try this at home. Do not build one of these in your garage. The Cartesian diver that Sarah and Michelle made, feel free to try that at home. We're going to put a video of this on YouTube so you can have the instructions on how to build the Cartesian diver. But the fire container and the lightning, don't try those. I hope you all enjoyed this and enjoy the rest of your day at the museum.